Okay, so let's get rid of this. What we need to talk about now is a thing called fields. Now, fields are an interesting thing. If you refer to the documentation that comes with this video, you will see that the way fields are described is a function that associates a value to every point in space. That's a little bit obtuse, I guess, but it's not that hard to understand. If you think about a plane, I'll just show that plane. Let's make it a little bit bigger. And I'll turn on anti-aliasing before your eyes melt. So this is a 3D plane. It's a plane in space, and it has points. Every single intersection of these edges are points. To calculate this plane, you're storing data that says this point is at this position. Whereas a field has an equation that calculates that point at that position. And you cannot access that data until you sample the field. This makes fields really, really fast. And there's a very, very good explanation in the PowerPoint. Field is a function that associates a value to every point in space. This is a scalar field. So what this basically translates to is that you have a float value for every point in space. And don't get me wrong, it is every point in space. It is infinite. So at any point you choose to pick in this field, a function will be run and it will return to you the values, the float values, at that point in space, no matter what that point is. Same goes for a vector field, except what it does is it returns vectors instead. So the examples are very good. So a temperature map of the top of South America and the bottom of North America and Mexico is a scalar field. Each temperature is a float value. So it's 32 degrees, 31.6 degrees, 15 degrees, minus 10, that kind of thing. Whereas a wind map would be a vector field, which, because as we know, a vector contains both direction and magnitude. That pretty much describes the wind. The wind is blowing in this direction, and it is this strong. So that's a real quick overview of fields. Let's get back to working with them. Bifrost contains both kinds of fields. Let's just do a real quick visualization of them. So I'm going to put down a fractal noise field, which is a scalar field. So this is just producing some random noise for me as a field. Now, if I wanted to take a look at this field, I've got a tool to do so, which is a scalar field scope. Like this. So it helps if you put some geometry in there to check it. So we'll just quickly put down a sphere. And I will hook everything up. So let's hook up the field first. Just a fractal noise field. And we'll drop the sphere, we'll make the sphere a little bit bigger, shall we? And maybe just a little bit higher resolution. Just fine. We'll drop that in there to the probe geometry. So now we can take a look at this field on the points of this sphere. And you can see what it's giving me is a visual representation of float values through the scalar field scope. And what you'll notice straight away is that there are holes in it. And the holes in it are because this field produces negative values as well. If I put a absolute value on top of that, you can see now that the holes are all filled in. And any changes I make to the field, for example, if I drop the magnitude, you can see the magnitude growing and dropping like this. Change the number of frequencies, change the frequency of the field. So you can see that the frequency becomes smaller and smaller as we change this. I can change the ratio, I can change the frequency ratio. all of that good stuff that noise gives you. You can also plug a time node into this field and have it evolve over time. So if I put down a time node, I need to convert my seconds to a scalar field and plug that in. So I can now watch that evolve over time. Very, very handy tool to have. You can also use this to put colors on things. So if I go to a assign diagnostic material, which is just a way to put colors on your geometry. Let's unplug this guy, plug this guy back in. It's going to be black at the moment because we have no data coming in. And the diagnostic material, as you can see by the color and the shape of the port, is a float-3 array. But what this is outputting is a scalar. So we'll need a different kind of field. Let's go for a fractal turbulence field, which is the 3D version of the noise field. And you can check this by hovering over the port. That's a scalar field and that's a vector field. So we'll just hook up this guy. I'll also use the absolute value, which means that'll break, which is fine. And then I can put that into here and you're going to get colors. A very similar thing can be done by using the node that we used in our last little exercise, which is I'm going to take this and turn it into a scalar to vector 3. It's the opposite of what we used. And these nodes work with fields as well, so I can plug the scalar value from the noise field into all 3 and then plug that into my emission color, and you will get a black and white version because of the way colors work. And you see that still changes over time. So you can visualize fields in both ways. This one as well, we can take our fractal turbulence field. That's going to give us all 3 colors, and we can watch that evolve over time as well. A bit slower, which is fine. And what we're going to use the field for is we're going to create a very basic terrain. So terrain is something that is used a lot in visual effects in games. You need to create a world to create terrain. We're going to do a really basic one. And we're going to do it basically with a couple of fields and a displace points. So let's get started on that. Again, up to you. You can create a plane up here. So Maya plane like so. Go forth and change its dimensions, change its subdivisions, if you so desire. Turn anti-aliasing back on so we're not all bleeding from the eyes. And you can drag that into Bifrost just as we did last time. Or if you wish, you can use Bifrost's plane, which you can then do the same thing. So if I set this to 25 and I set this to 39, I'm going to get the same result if I plug that in. And remember, hide your Maya object. Like so. Let's just turn on that so we can see what's going on. I'm going to get the same result from the plane coming in as I will from the plane in Bifrost. So nothing's changed there. So just for speed and ease and keeping it all in Bifrost, I'm going to use Bifrost's plane. Let's just get rid of those input nodes. Except I'm going to make this probably a little bit more, even further, a little higher resolution. So we've got 256 divisions on each side of the plane, and the plane is 25 by 25 units. So let's get ready for the world's absolute simplest terrain. And here's the process. We have a plane. I need to get a field onto that. And yeah, I want to visualize that field, so let's do a scalar field. What we're basically building is a height field here. That's not going to work. Oh, no, I'm going to need that later, so I'll just pop that down there. Let's go for our fractal noise field, because fractal noise is our friend. And we'll do a scalar field scope, just like we did before. We'll plug in our plane as the probe geometry and our noise as the field. And let's just take a look at that. In fact, why don't we just take a look at both? So this is showing me, without, of course, without the negatives, what my field looks like. And this is really good because I can now go and I can change my frequency. If you imagine this, these will become your hills and your blank spots here will become your valleys. Also, you can absolutely color remap your field if you want to. So you can get different colors and things like that. Change the point size it's displaying on, whatever you're happy with. Size remap here. So if I was to do something like the position was -1, then with the size remap on, let's just center that, I'm actually seeing my negative stuff as well, which is fine. And I can do the same here with the color remap. Just get that back to a default. So, and I'll take this and I'll make its position -1. So now I'm getting a full view of what my field's going to do. If I wanted to be a little bit more aesthetic, I could do things like add more green into the top or more green into the bottom, that kind of thing. It's all up to you, how you want to see things. But right now I am seeing both my negative and dark, let's just hide that plane, both my negative and dark values, which are the blues, and my positive and high values, which are the reds, or the other way around. Easy way to find out, let's make a terrain out of it. So, simple way to do that is the node we've just used, which is displace points. And if I then plug my field in to the weights and output this to my output, you can see, and then just to make things look even nicer for us all, I'll plug this into my probe geometry. Now you can see the field and its displacement. And that is a very, very simple terrain. Let's turn off the field for now. So I can do that a couple of ways. I can unplug that, so it just disappears, or I can use the first logic node we're going to talk about today, which is an if statement. So I can put if in there. If I plug this into false and hook this up, I can now quite happily switch between the two viewing modes. So when it's true, I'm seeing the scalar field scope, and when it's false, I'm seeing my plane. Very handy node to use because now I don't have to disconnect this. The way I'm going to do it though is I'm going to plug this one into here so it's always visible and take it out of here. And what that means is that when it's false, nothing will display. When it's true, I'll be able to overlay my field scope on top of my geometry and take a look at it that way. And I can make some adjustments to my field scope, like making the points a bit smaller so it's a little easier to see, change colors, change my divisions, do all that kind of thing as well. So that's pretty good. I'm well on my way to making a terrain. That is essentially the basics of the process. We're going to go through a lot more that involve stacking and adding fields, multiplying fields, stuff like that. But that's the basis of it. So we can, of course, come into our field. We can change everything pretty much in real time. So you can go with something like more gentle rolling hills, or you can go with a bit more rugged terrain like this. But again, we're going to need to do some modulation on this. So if I want to, say, flatten the bottom of my valleys, we're going to go back to our old friend, the fCurve. And before we do that, I'm just going to put a pass node in, because I want to have two outputs from one input, which is great. And there is such a thing in Bifrost as an fCurve field. And this is pretty much like evaluate fCurve for geometry. If I plug this into the field, like so, you can see immediately I've lost all of my negatives because my field by default is from 0 to 1. If I want this to appear the way that I set it up, I need to take this guy and believe it's his value, other way around, both. So that's going to give us back what we had. And what the field's doing there is if we just center it, it's going from -1 to 1, -1 to 1. Fractal noise is not quite -1. It's not quite -1 to 1. It's more like -1.1 to 1, but close enough. What I'm wanting to do here is I'm wanting to flatten out my valleys. Okay, so easiest way to do that is take the lowest point, which is -1, -1, and put a curve into it like this. And I can then start moving that up to get more flatness. And that's a gradual displacement from where it was, which was -1, -1, to -0.5, -1. And now I'm starting to get messes. So to avoid the flat tops of our ridges here, I can just zoom out on my graph a bit, and I can just start pulling this along. So now what's coming in is being remapped out to about 1.5 at the top. And again, we can have that gradually change like so. So you get a lot of control out of one curve, which is what they're for. They're really good for modulating stuff. So now I've got some nice flattish valleys that still contain detail down there. Let's just turn off our scope for a second. So we can. So you've still got some details down in here, and I can go to the field and say add another frequency, so I get even more details. I can change my frequency. I can still, because it's procedural, because it's non-destructive, anything I do back here will just ripple through and give me what I want further on down the line. So I can do something like this. And you can add more and more detail to the point where you run out of resolution on your mesh, basically. But now we've taken what was very much a basic noise, which is what that looks like there. I'll just pull the field out of it for now. Just with some small tweaks, we've made it look a little bit more like a terrain. So we have hills, we have valleys. One of the other things I like to do too, which isn't really covered in the first lesson, but I think it's worth including here, is I like to translate my field a bit. And translate field is super simple. You put the field in the field hole, and then you can change whereabouts the field is sampled. So you can move the field around behind the sampling. So let's say I just want to move this into Z a little bit. You can see the fields moving along. I quite like these flat bottoms here. It's quite nice. And maybe we can change the X a little bit as well. So now you've just got, the difference is this to this. And I just feel that's a little bit better varied terrain. It's possibly a little too flat in here, which means I just need to come into my fCurve field, bring that in, and if I just start very gently pulling up this bottom, you can start to see detail coming back into the lowlands there. Up to your preferences, really, how you want to do it. I quite like that. It's pretty good. And so let's ignore that because it's not really covered in the first lesson, but that's okay. Yeah, we'll ignore the translate field, just pretend it's not there right now. It's something I've added in. But with 1, 2, 3 nodes, we've been able to get a reasonably good looking terrain. Certainly good enough for stylized work. And again, non-destructive and procedural. If I wanted to make that higher resolution, I could just come in here and change it. And you can see that detail's added, or if I wanted something a bit more low polygon, take it all the way down to even 32 segments. And you can see that it's pretty chunky, but it's still keeping the same shape, which is pretty nice. So we've got our very basic terrain going on. And the main parameters that you will be adjusting all the time is the magnitude and the frequency. Those are the two really big ones that you find yourself using over and over again. You can think of number of frequencies as literally a detail. So if I take that down to 1, it's really, really soft. Almost no detail at all. If I take it back up to 6, it's adding details as it goes. And this is a function of how a fractal noise is generated. Also, we're not going to use it here, but you can change things over time if you want as well. But remember, magnitude, frequency, and number of frequencies. Frequency ratio allows you to change how the frequency is calculated through the layers. Sorry, that was ratio. And frequency ratio allows you to change the frequency up and down. Now this is looking pretty grey and boring, so let's get some colors on it. Before we do that, I'm just going to make it a little bit higher in the top. I can do it with the original field, or I can also do it with the fCurve field by grabbing this guy and just lifting him up a bit. If you go too far, of course, then you have to start pushing them along as well to avoid the Mesa look, unless that's what you're going for. But you get to the point where you're quite happy, like I am, so I've just got a little bit more difference. A hilly landscape with maybe a little more like that. Cool. Let's get some colors on that. Now, never mind this sort of stuff, which is just for visibility. Again, if I wanted to see how the field's reacting to that, I can do that. And this includes the fCurve field, because it's coming out of the fCurve field. This is just displaying the field and what we've done to it. Good to get some colors in there. And we're going to do a real simple one. We're going to go from the bottom at one color to the top at another. And this is very much like what we did when we put oscillations onto our sphere and cone earlier. So if I take my displaced points and I get their point position, so, and convert that to, convert it to scalar values. What I'm looking for here is the Y value, and I want the Y value to be one color at the bottom, one color at the top, which is awesome. That means that my Y values right now are, if we go over to our right view and turn our grid on, it's sort of like minus 0.25 to about 1 3/4, something like that. Not going to work for us. What we need to do is make that range into a 0 to 1, so we can use a linear interpolation to change the colors. And we've done this before by getting our bounds and doing a change range. Both of those get plugged into the Y, and then the minimum into from start, the maximum into from end, and I can just change that to 0 to 1. So that's taken those values and remapped them to 0 to 1. Again, because I might want to make some changes, I'm going to put in a evaluate fCurve, so I have more control. Now, when you add fCurves like that, it plugs itself into the first port, which is not what we want. We want it in there. That's why it went yellow. And then lastly, what we're going to do is a little linear interpolation. Now, if you've never run into this before, what this does is it mixes between this value and this value by a fraction, which is why we've changed this into 0 to 1. So if this was 0, it would be 100% the first input. If it was 1, it would be 100% the second input. This, what we've been building based on our Y value, is our fraction. And I'm going to go in here and just change these to MathFloat 3 so that I can put colors into them. And we'll leave the first one at black, and in a bit of classicness, we'll change the second one to white, just so we can see what we're doing. So what we've done here is taken the Y values, we've remapped them to 0 to 1, we've put a curve on, which we'll come back to in a minute, and we're outputting black at one level and white at another. Now we need to see it. Assign diagnostic material as our friend here. Pop that in there. It's going to go completely black because right now there is nothing connected. We'll just connect this to it. Let's connect it to the right spot. And you can see what's going on now. Is if I turn the grid off, the further down towards the lowest point you go, the darker it gets. As you go up towards the highest point, the lighter it gets. And I will do this with a curved fCurve, so you're getting much more contrast there. And of course you can adjust this to your heart's content. So if you just want the very tippy tops of it to be white, do something like this. This guy you could adjust so you've got more detail in the grays. And once we're done and happy with our ranges like this, we can change our colors. So let's go for a kind of a dark greenish color at the bottom. I have some values here that I'm pulling off the PowerPoint. And then we'll go for a lighter green at the top. But now we've got a nice graduated color scheme from our lowest point to our highest point. Here's a little trick with fCurve fields. And this is quite a good thing to remember going forward, is just about every single port on every single compound, I can go right click on it and say create a value. And what this will give me is the curve that I just set up. If I disconnect that, nothing's going to change because this curve is the same as that curve. But what it does allow me to do is copy and paste, Control C, Control V. I can make a different curve. So let's say that I would like to make some mesas. So I try to bring that back to, oops, wrong one. Bring that back to 1. Let's hook up this curve. You can see it's changed the way that everything's done and changes the way things look. So I can keep working on that curve to get a different, kind of a different view. So I can do something like that, or even lift up my baseline, get something a little more interesting like this. I can absolutely change that curve back and I'm where I was before. And you can repeat this as often as you like. You can make another one. And what we'll just simply do here is we will just reverse it like this. I can plug that one in. So now our original curve looked like this. And now all this has done is reversed it and flattened the top. So it's a feature of how procedural the system is, that you can make as many of these as you like and choose between them. You can turn them into an array and choose between that as well. I'll show you how to do that very, very quickly. This has no bearing on where we're going, except it's a very handy thing to have. So we do build array, and I'm going to put each one of these into the array. And then, because this only wants a single fCurve, you can see there's no hat there, but there's a hat there, I can make a little node called getFromArray. And this allows me to get from this array coming in via this index. And an index of an array is the number of that particular entry into the array. They always start at 0 and they always count upwards in integer gaps of 1. So 0 in this array is this curve. Let's check that 0 and plug it in. There we go. Because our curve on the field and our first curve are the same, you don't notice a difference. Let's just fix that by going in here. We'll put in the wacky preset, so that's what it looks like when there's no field plugged into it. Now if I plug this field into it, which is the first one, number 0 of this array that we've just built, then I'm getting this field. I can then change the getFromArray to go through the values in the array very quickly. So that's just a little tip if you're trying to do different versions or wedges or whatever it is you're trying to do. You can apply this to anything as well. So you can use the same value in a different array to get different colors, for example. If I wanted to change the colors in here, I could build an array of firsts and an array of seconds, or even an array of looped colors, and just choose the same one as we went, which allows you to change styles and setups very, very quickly and easily. I think what this array is desperately needing now is some lakes. So we're going to talk about layering some fields. So this is the field that, over here, this is the field that makes our terrain. What happens, say, if I want to drop some of the lowest points here, or just really anything, down underneath everything else and then use them as lakes, as water. So what we'll do is we will make another field to do that. I'm going to turn on my field visibility here. And there's a couple of ways to do this. What I'm going to do is create, first off, I'm going to, remember that scalar field I made by mistake? There it is. We're going to use that now. So let's set that to something like 0.22. And I'm just going to add these two fields together before it goes into anything else. So we'll use our add node like that. There we go. And then this guy goes in here. You can see everything jump up. Because what it's doing is it's taking every value in this field and adding 0.22 to it. If I change to that, you can see that the field is lifting or dropping. Yeah, so when we're adding a positive number, let's get that back to a positive number. What we're doing is we're enlarging that area of the land and decreasing the area for the lake. So it lets us, if you imagine our lowest points are lakes, and I just change this to 0, you can see there's more lakes. And as I take this up, it's adding more value to the land. You'll see the lake area getting smaller and smaller and smaller until it's gone. So this is just one way to add to one field and change the ratio between lake area and land area. I mean, we should probably take a look at what a lake might look like. So let's just grab our plane. We're just going to make a guideline here. This does not have to be high res at all, but we should give it a material so that we can get a better idea. And I'll put this into another if statement as well, so we can turn it off and on. Basically, what I'm going to do is I need to put a solid color in here. All I need to do is change the value type here to float 3, and it's going to use the same color for every point on this plane. And that color I'm going to do is something like this. Let's pop down an if statement. Again, just so we can turn it off and on, we'll leave the false blank, and then we can plug that in. We turn it on, and you start, that's our lake level. And with our lake level on, I can go back to our field here, where we added, and you can see how you can increase and decrease the ratio between the land and the water. So we'll just do a little bit of work to get our own field for the lakes right now, because we're going to bring in another node in just a second. So I'm just going to grab this guy, and this guy, copy and paste, and then we will just hook this one up to our translate field. So right now we're not using this system to control anything right now, but we are going to use another field. Let's get this back to 0.22. And let's start to keep things a bit tidy in our graph, because things are getting a little bit confusing. And Bifrost lets you do that in a number of ways. And probably the best and easiest way right now is to use a backdrop. So this is a Bifrost backdrop. It literally just is a backdrop. We can call this mountains terrain. Make another one around here and call it lakes. And just to keep ourselves busy, we'll make that one blue because we know that lakes are blue always, and we'll make that one yellow because we live in the desert. You can move all of these nodes around just by grabbing the top of the backdrop and moving it around, and it just helps to keep things organized. So now what I'm going to do is introduce a new node. Don't forget we should have a pass going in here somewhere. There it is. We can also pop a backdrop here and just call this fCurve array. What I'm going to do though is I'm just going to use one for now, like that. I will make this a yellowy color just for now, because this is just a little technique I was showing you. We don't actually need to do this kind of thing. We'll just use this fCurve, which is fine. It's the one that we set up before anyway. The next node we're going to talk about is switch fields. Switch fields. So this is a lot like an if condition. Very like an if condition. What it's basically saying is it returns a field whose value at each position is from one of these two fields, the true or the false case, based on this condition here. So to give you an idea, yeah, we put our mountain field here. Let's do that after the fCurve. Let's just get these guys up here and extend our backdrop because it's good to do that. Just tidy this up a little bit. This is going to be our true condition. So if the condition is above 0, if our condition field is positive at any position, this will be the field that comes out. If it's negative at any position, this will be the field that comes out. And what I'm going to do is use this as my condition as well. So if I plug that in to our pass, you can see what happens straight away. There's a problem around the shorelines because it is, let me just turn off the field view, like this. And you can see that when it hits that condition, it just absolutely cuts off. Boof, boof, boof. So it's forcing that through. Because the mountain and lakes are generated from two separate fields, there's no smooth transitions at all. we need to create some. And we need to do it in the mountain field before we connect the switch field. So the way we're going to do that is by more field layering. Just move this off to one side for a second. So I'm going to take my lake field and I'm going to put it into an fCurve field because we're working with fields. And then I'm going to multiply my mountains terrain by that. And this will allow me to modulate this field and then create transitions with it because we're basically multiplying. This will turn everything to 0 to 1. I'm just going to quickly set that to there. And I'm going to make it very high contrast. So we'll take that somewhere like that. And now let's replace our true case in our switch fields. And we'll just move the rest of it along a little bit with our new multiplied field. And you can see it's now creating shorelines because the fCurve, if we take a look at that, is absolutely flat until about 0.5. And so you can see that there where we're getting a gradual shoreline because we're using this multiplied, a modulated version of our lakes, multiplying our mountains. We're starting to get this. Now you can change the shape of that by just playing with this. If I change that to something like this, it's much more of a smoother transition and it's looking pretty good. I'm going to change my color scheme, or actually what might be better here, so we can see the fields. And so you can see how it's a gradual transition from the lake areas to the mountain areas, which is what we were after. We're essentially using the fCurve field that we've put in here as a 0 to 1 gradient. And what this is saying is we want to blend smoothly from this field to this field across this gradient. And we end up with some good looking shorelines and islands. And again, you can come back to the field and you can come to this field even and change stuff and you'll get different versions and different looks, which is all good. And we've got hills and lakes, which is looking pretty nice. And keeping with our organization, I'm just going to grab these two. Let's make a backdrop. Call that smooth transition, which is cool. Let's pop that guy back up in there a bit more and we'll just put this here so that there's our lakes, there's our mountains, there's our smooth transition, and we've got everything just a little more organized. Now, because this is noise and because this is procedural, really all we have to do here is we can start changing our seed and you get a different lake distribution. We can change this value to get more land or less land. So we've got a lot of options here. We can change the lake seed to get different distributions of lakes as well. We're starting to look pretty good. I'm going to change the color of my lakes because they are very bright blue at the moment. And that's here and here and here. So really what I want to do is make that darker. Yeah, that looks a bit easier to read. That way we can turn off our display. You can also, if you're messing with things, you can take this plane and just change the water level too. So this is different from changing the field. This is changing the level at which the water is. So if I wanted to just have fewer lakes like that, I could drop the water level there to minus 0.05 or minus 0.1. And again, changing the seed here, you get different lake distributions. You can have different translations, things like that. So that's the basics of a terrain system, a really basic one.